Alright, time for binary multiplication. This one's really cool. We're going to use a adder on a loop with some shifting and stuff. It's going to be really cool. This is one of my favorites. So let's do it on the table first, like how you would do it in elementary school. You just take this bottom right digit and you multiply it by the first one up here, and then the second one, and then the third one. In binary, it makes it really simple because it's either going to be 1 times the whole number, which means you're just copying the number, or it's going to be 0 times the whole number, which means you're not adding anything at all. So let's do this piece by piece. So you start with the 1, you multiply it by this whole number, and I'm literally going to copy and paste it because it saves time. Paste it here, and this is the first part of our answer. We did 1 times 1 gives the 1, 1 times 1, 1, etc. And we copied the first answer. Now since we have a 0 for the second one, we do nothing, but I'll draw it anyways just so you can see what's happening. We shift it over by 1, and we do all the multiplication, which again gives us all zeros. Now since the third one is a 1, we copy this number again, and it gets shifted over again. And then the fourth one is a 1, and it gets shifted over again with the exact same number. And then you can just put another line here, and you would add all of these up. So I'll just do the addition live, and we'll double check that we get the right answer. So 1 goes here, just a 1. 1 plus 0 is 1. 0 plus 0 plus 1. 3 ones gives us a 3. So a 3 is a 1 with a carry. 1 plus 1 is 2. A 2 is a 0 with a carry. 1 plus 1 gives us another 2, which is again a 0 with a carry. 1 plus 1 gives us another 2, 0 with a carry. So let's see if we did this right. So 1011 is 11. 1101 is 13. 13 times 11 is 143. This is 128 plus 4 ones. 4 ones is 15. 128 plus 15 is 143. So we did it. So what we've shown here is that all it takes to multiply two binary numbers is to take the first number, shift it a bunch, and maybe take some out as you go, depending on where the zeros are in the second number. Because what I mean by that is if you go over here and you put a 1 wherever there was a number, a 0 wherever there wasn't a number, you're going to get this, which is exactly our second number, but in reverse. Because that's what we're using to decide whether we write it down or whether we don't write it down. So I'm going to try my best to describe how this works. This is the schematic for the actual multiplier. The red is one number that we're multiplying, the blue is the second number. I put a repeater and a comparator here to resemble the fact that as we shift blue to the right, this lowest bit, this rightmost bit, is going to determine whether A, this red, is going to be canceled or not. So in other words, if this lowest bit right here is a 1, then A is sent through, no problem. If it's a 0, we're going to cancel A. In other words, it's just going to be all zeros. Now this output is sent back into the front of the machine. And of course, this orange is an adder, and it's going to add this first row, whoops, with the second row. It can't see this lowest bit here, and this lowest bit is going to gradually give us our answer. That's why I put a record here. Part of the step on each loop is to record the lowest bit, and that will gradually give us our answer. So let's try to do 3 times 3. So we have 3 right here. Our lowest bit on the blue is a 1, so we're good to go. 3 plus 0 is 3. 3 comes around here, gets put into here, and we record the lowest bit like this. So whatever this is, I literally just copy it to here. Now we're going to repeat. So we shift this over, to the right, and our lowest bit is still a 1, so we still don't cancel or anything. But now, instead of our adder doing 3 plus 0, it's going to do 3 plus 1. 3 plus 1 is a 4. 4 comes around and gets put into these 4, and there we have it. Our answer is 1001, which is 9. So let's do another example. I'm going to do 5 times 5. We have 5 in the red and 5 in the blue. When we go through the first time, this is a 1, no canceling needed. So 5 plus 0 gives us a 5. 5 comes around, gets put into here, and we record the lowest bit. So the first digit of our answer is a 1. Again, I'm just copying whatever this is and putting it here. Now, before we do our next loop, we of course need to shift this over. Now, our lowest bit is a 0. So for the first time, we actually need to just turn this off, completely cancel it. It's equivalent to this second row right here when we were doing it out on paper. So now the adder is going to do 0 plus 2, and of course that's just 2. 2 gets sent around, gets put into here, and we're going to record the lowest one. So bring this over, copy it, and shift this over. Now we need to start our third and final loop. This number gets shifted again. This last bit has become a 1 again, so now we can send in that 5. It no longer needs to be canceled. 5 plus 1 is 6. 6 comes around to the back, gets put into here, and we are done. 5 times 5 is 25. 16, 8, and a 1. Now, this is the 16-bit multiplier that I used in the calculator, and I'm going to be trying to build this with the tutorial. So, because it's using loops now, it's not as simple as just flicking the levers and watching the answer appear. We do need a calculate button and a clear button, just so that we can tell it to run and clear when we're done. So I'm going to show you the 5 times 5 we just did on an actual multiplier. So 5 times 5 is inputted, it's this blue and this orange. And when you hit calculate, notice how this bottom bit is getting saved every time and shifted over. And eventually our answer shows up as 25, 1, 6, and 18. Alright, so we're going to start with our 8-bit adder as usual. I got rid of all the carry and stuff, it's just going to get in the way anyways. Just make sure to keep it off. We're going to take these outputs and shift them down by 1 by the time they come around. I'm going to hug it really close to the adder with no space in between. I'm just going to put a repeater here, 1, 2, 3 blocks, down 1 with the slab, and then 2, and then 1 up. Repeater here, redstone dust on the rest, block this off, and then I'm going to do something a little weird. I'm going to take this 1 by 1 part of the actual adder and stack 1 this way. It won't affect the adder at all. It'll just reduce these lines interfering with anything. Because see right here, we need to block another one off right there. Now we can actually stack this whole thing 7 down. So this part, 7 down. Actually, let's just do 8 down because we're starting from the carry out. Take this part. Actually, take this entire part. Stack 8 down. There we go. Now what you want to do is get rid of this bottom one. Put a repeater here, starting on this bottom bit. Bring it up by 1. Cancel it with a repeater. Make it like this. And then you're going to stack this part 7 times. And you can just put a torch right here for now to lock all of these. And then we're going to do something similar over here. We're going to build, starting from here, more repeater locks. So I'm going to put a slab like this. I'm sorry, a block like this. And I'm just going to power it for now using a redstone block. And now you can just stack this whole thing up. You can stack this part. Stack 7 up. Slab tower. Stack 7 up. You might have extra. That's okay. Get rid of that, and then make sure the top one is locked. Now we can also build part of the clearing mechanism. This is going to use sticky pistons. And you're going to build up like this. And make another slab tower thingy. And you can just stack these. 7 up. Take this. Span 1 up. Stack 7 up. And there we go, get rid of these, and then you can also just power this for now with a torch right here. Now, since one of these inputs is pretty much always either going to just be sent in or nothing at all, aka the red one over there in the schematic, we're just going to control for that using some pistons over here. So grab a sticky piston, and you're actually going to build it right here. And you can already put a lamp for one of your inputs. This is where input A or whatever is going to be. Span 1 down, stack 7 down. There you go. You can also go ahead and put lamps for the rest of your inputs. So we know that this is going to be the top one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. When we're multiplying two 8-bit numbers, we get a max of an 18-bit number. And as you can see, I think from the other one I had signs, but I'll just put some signs here too. This is the lowest one. This is 1. It goes all the way up to like something crazy. I don't know, 32,000 or something. Yep, 32,768 is your top bit. And it goes in an L shape all the way down like this. We want a bunch of repeaters as if they were going into these blocks. So take this, stack 7 up, and I'm going to make a tower like this. So I'm going to put the clear button 9 blocks out from this. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and then an extra block, and put a repeater here. You can get rid of all these, and then grab a lamp, and you can put it here. So I'm going to make this clear button split like this. It's going to come down like this. 1, and 1, 2, 3, 4. Bring it all the way across out to here, and then you can start going up like this, and just keep bringing it up. And then this is going to have to be a sticky piston here, and then there's going to be a slab here, and a slab here, block here, and then we actually want another piston here, and then you're actually going to have to bring all these blocks up. Block here, repeater on 2 ticks, redstone under these, and then redstone on the entire thing. And you'll probably need another repeater along the way here. 2, 3, 6, 7, 8, 9. Yep. And then the clear also has to do one other thing. It has to open up the machine. So we're going to go like this. And so now when we press this button, it's going to pull back all these pistons, killing all these lines, and it unlocks all these repeaters by making this piston pull back the redstone block. And I almost forgot, we also have to clear the ones that are down here. So to do that, just make a repeater, put it on 3 ticks, go like that, and now these will all be unlocked as well to let everything flow out. Alright, so I'm going to label it so I don't forget, get a sign, clear, and then let's also make the calculate button. So that one's going to be here. Grab a button, but also label this. Repeater here. Block here. Another block. Yeah, you're going to want to do a pattern like this where you have like 4 blocks coming out, and then bring these over here, and then put some blocks in between here, one in between here, and one in between here as well. Now pistons, sticky pistons go under this block and this block, and another block here, whoops. And then you want a repeater on 3 ticks here, a repeater on 3 ticks, 3 ticks, and a repeater on 2 ticks right here. And then the rest can be filled in with redstone. And now you need a comparator here, and a block, and redstone. So this is essentially going to create the loop that we're going to use to count how many times we shift this through. And it's going to shift a total of 8 times before it gets to its final answer. Now we also need a way to stop it when it's done, so that's what I'm going to build here. So right here, build a redstone like this. Down 3. 1, 2, 3, 4, 5, 6. And this is all going to be normal redstone. And then 1, 2, 3, 4, 5, 6, 7, 8, and a slab. And these are all going to be repeaters on the max length, which is 4 ticks. And then this is going to flip itself around like this. 3 ticks right here. And we're going to make an extender. This is a pulse extender. 1, 2, 3, 4. Put it like that. Build this all the way out. Redstone all over it. And then go up like this. Make blocks like this. And we're gonna make a torch tower out of these. So like, I'm sorry, not one there. One here, 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 and here. And then this is gonna power a repeater into a block, into a redstone dust, which is next to a extended piston here. And so that is one giant loop that's going to basically come down here, wait a lot of repeaters until it gets back, and the repeaters are exactly timed for how long this machine is going to take to do one calculation. And then when it's all done, this will turn off, which retracts the piston and closes the loop. And I also forgot to make these 2 blocks right here and these 2 redstone. It's really important ones because that makes the loop unlock and lock these repeaters every time, which is essentially capturing this last bit and shifting it over. It's responsible for half of our answer. And since this circuit already times how long it is for us, we can also use it to just lock the repeaters at the very end, which we need to do in order to save the answer. So I'm just going to make 3 more like this, all with 4 ticks. Yeah, block here. Another repeater, redstone, sticky piston, block, repeater, block, block, dust, dust. There you go. So at this point, what this multiplier is doing is it's multiplying your A number with all ones because we haven't coded for whether it's sent in or not every time. Right now it's just being sent in no matter what. So that's the equivalent as just doing all ones. So let's try 3 times 8 ones. Let's clear it first. Make sure the lamps are off. Hit the calculate button. And there you go. 1 0, 6 ones, 0 1. And I've already checked that. That is 3 times 8 ones. One correction is this sticky piston pushes up on this block, so you're gonna have to move all these up here like this. So in order to make a system to block this whenever there's a 0 in the other number, I'm first gonna make a big spiral tower right here, starting from this repeater and then going up like this. And it's gonna be 14 blocks in length. It's gonna reach nearly the top, so I'll just build it up here, but I think it stops around here. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and the 14th one goes out like this. Now I'm going to make our second input. It'll just make it easier to line up. So put this here, put a lever, and then there's going to be a sticky piston right here, and a torch here. So now you can take this whole thing, stack 7 down, and there you go. So what I'm gonna build right here, and this is really hard to explain, but I'm making a tower, right? And each level of the tower is each bit in our second number. As this goes through the 8 loops, so let's say loop 1, loop 2, loop 3, those are going to be synced up with level 1, level 2, and level 3. Now each level is obviously coded with our second number, and as it goes through these loops, it's going to look at each level, and if that level is a 0, it cancels it. If that level is a 1, it lets it go through. That's why we're connecting this spiral here to all the levels, and this whole spiral is connected to a comparator to cancel it. Because if it's a 0 at any level, it will power this line and cancel the number. If it's a 1 at any level, it won't do anything with this line, and the number will go through as normal. It's kind of hard to describe how to build this, so just bear with me. I'm gonna do it column by column here. Obviously, first put blocks on these. Then you want to put a repeater, block, 2 repeaters, another block. Take this whole thing, stack it 7 down, and then put redstone on every other one. So it's gonna start with a repeater at the top, redstone here, redstone here, redstone here. Then you want to take this guy and stack it 7 down and alternate all of these to be repeaters until your last one is all the way down here, barely powering this block, which still reaches the end of the loop. Then you want to take in between these blocks and build like this, and then build 2 arches like this, dust here, repeater here, and then a torch on the inside of this, and then torches like this as well. And then you want to take this pattern and stack 7 down, and then you don't need this top one, but what you do need is to continue these torches all the way on the bottom here. And then obviously you can get rid of this. And then you actually don't need these two, and you also don't need these blocks here. Then in order to start the tower from the bottom, you just take this line, which is from the calculate button, into a block with a torch going up, block like this, torch to the side. And another small change, all of these have to be 2 ticks instead of 1. So with the tower done and the canceling being done accordingly, we should now have a 16-bit multiplier. Really cool. So let's try it out. Let's do something huge. I'm just gonna test something really big out, and then I'll put it on screen. Alright, make sure there's nothing in there. Calculate. And this is correct. We just did 173 times 223 equals 38,579. Awesome. Alright, before we copy it to the calculator, I'm gonna just bring these two inputs out to the front so it fits easier. I took this one and did a dot and a redstone repeater, and then this one just has a repeater and a line all the way out. I'm just gonna copy this whole thing. One here, stack 7 down, and these should be our inputs. Put repeaters on it to line it up better when we copy it. Actually, we're gonna need to bring it out more. Bring it up to about here. Then put dust. And then stack this up again. So keep the calculate and clear button where they are when we copy it. And let's take a corner. This should be fine. Other corner all the way down here. There's a bunch of lines underneath, so gotta make sure to go as far down as the lowest line. And then my reference point is going to be on the top here. Destroy this. Copy. And then just like before, bring the A line out front. Bring it down with some slabs. And then put B through A. Paste. Dash A. Everything fits. Cool. Alright, I say we test addition, subtraction, and multiplication all at one time. Eventually, we're gonna get to switching between these modes and all the cool automatic stuff like that, but I'm gonna save that until after the division episode. There's gonna there's a whole lot of little logistics like that I'm just gonna cram into one giant like logistics episode, and so let's do 182. I don't know, man. 210. 210 minus 182 should be 28. And that is right here. We have 16, 8, and 4. I'm sorry, yeah, 16, 8, and 4. That gives us 28. 210 plus 182 is 392. 392. You know what? I'm gonna trust that's 392. I think our adder's working. That's typically the most the most reliable out of all these. All right, multiplier time. So the inputs are in, but we still have to hit the calculate button. And while it's going, 210 times 182 is 38,220, and I just checked it with this number, and it all works. So now we've done math with 3 different operations. Thanks for watching.